Okay, so everyone should have their notes in front of them. I don't have any extra copies, so hopefully, or just everyone's got their notes, hopefully. Okay. And I think we've seen this before. And so we're just gonna kind of just kind of rest on this problem. It's only 2 pages. We're gonna rest on this problem here. Pretty straightforward, hopefully. I'm not gonna use a calculator. We should be able to use a calculator. So let's look at 1 over x. Okay. So 1 over x. Give me one number x cannot equal. If it's 1 over x. Go ahead. Yep, true. Can't be 0. Correct. So what you're going to do, just like the log question, should be page 25, I think. That's right. The whole homework and notes are the same package.
What was this?
That's homework. That's what we're going to do today. I'm not going to chance to go over right now.
Okay.
Actually, you could do it during class today. Don't worry about it, guys. Don't. Homework I know is very tough to do during the week. APs, trust me. Like A push, for example, I got out of 2 lower division history classes. I got 4 on it. I save thousands of dollars and lots of time. I'd rather you do that than do a homework assignment that's going to be like 5 points. Like seriously, I understand how important these APs are. So next week, same thing, right? So I get it. Don't worry about it. I'll sign it, but just do it when you can. So anyway, guys, let's keep going here. I'll get off my soapbox about AP exams. All right, so okay, so that's good, Catherine. 0 is not okay. Now plug in numbers that are okay. LCMS. So if I plug in 1, what's 1 over 1? 1. What's 1 over? If I plug in 2, what do I get? 1/2. Good. Okay. And if you keep plugging larger numbers for x, like say I plug in 10, what's 1/10? Like 0.1, right? So you get really tiny. I'm gonna do green for those dots. Okay. Also, what if I plug in? And it's hard to see right now, but there's little green dots. Okay. Let's look at the vertical asymptote. This is why vertical asymptote truly exists. Let's plug in 1/2. What's 1 over 1/2? What happens when you have a fraction on the bottom? So what's 1 over 1/2 then? 2. How about 1 over 1/10? 10. So as x gets closer to 0, yeah, and John, be careful. You're a little too strong. Yeah, 5. Okay. All right. So anyway, as x gets closer to 0, y gets really large. That's why the graph behaves this way. And that's why we call it end behavior. Ends of the graph. Arrows are ends, clearly, right? How is it behaving? It's getting closer to 0. Why? Because numerically, right. If x gets infinite, y gets closer to 0. If x gets closer to 0, y gets closer to infinity. That's why we have this behavior. Okay. Now, what do you anticipate on the other side of the y-axis?
As x goes closer to 0, y is closer to infinity.
Well, if it's closer to 0 on the left side, if it gets closer to 0, like negative 0.1, negative 0.5, negative 1/2, right? It's going to be going down. Like what's 1 over negative 1/2? It's negative 2.
Yeah.
What's 1 over negative 1/10? Negative 10. So it follows the same behavior, but in the opposite direction. And if I plug in negative 1, I get negative 1, I get negative 2, and so forth. All right. So that's how the graph looks. Okay. This. You have to have this image embedded in your head. Like, okay, this is when I see 1 over something, that's what I expect. After this, all we're doing is shifting the graphs around. That's all we're doing. So if you think about it, if I add 3 to the outside, we know when we add something to the outside, it does what? It goes up, right? Or if you subtract something from the outside, it goes down. But if we do it directly to x, it shifts vertically, right? So what we're going to do is now do this graph off to the left, then answer B, C, D, E afterwards. And that's really the whole essence of this lesson, is how do we graph a rational function, right? Graph a rational function. It's the whole essence of this lesson here. So let's talk about it. All right. So now let's back up a little bit here. What's not okay for the bottom here? What's not okay for x? If 1 over x plus 2, what am I not allowed to plug in? Negative.
Very.
Negative 2. Negative 3 is okay. Don't think that plus 3 we worry about later. Negative 2 is not okay because you can't divide by 0. So when I do my tick marks, I'm going to draw an asymptote there. Get that asymptote out of the way quickly. Oh, another thing I forgot to mention for the original graph off to the right, there's a vertical asymptote clearly. There's also a horizontal asymptote. I forgot to mention it. There's a horizontal asymptote on the x-axis. Because as x gets larger, y is getting closer to 0. It's another boundary. You have two boundaries here, okay? Come back to this one here. Negative 2 is a boundary. We know this now. So let's draw the boundary for negative 2. Okay? Negative 2 is a boundary. Okay. Now we're getting the hang of this shifting stuff, right? The plus 3 shifts 3 up. Okay? Reggie, I need you to take this. You're on the wrong page too. Thanks. All right. Okay. Yeah, thanks. You color. All right. Okay. So we had a horizontal asymptote y equals 0, right? Because when x got larger, y got closer to 0. We know this. If you put plus 3, what do you think is going to happen to this horizontal asymptote? It's going to go up 3. So I'm going to do a dashed line at y equals 3. When you set up this these asymptotes right from the beginning, it helps establish the foundation of the graph. It's almost like you're aiming at the right place, right? I know she'll be talking about aiming, but anyway, you know what I'm talking about. We're at school. Like shooting games, you know, like Fortnite or my nephew plays it. So actually speaking of which, his birthday's tomorrow, so I need to
Happy birthday.
anyway, so you shift it like this, right? So you have that right there. Okay, now we're gonna plug in numbers. When we plug in numbers, you can plug in random numbers, but personally I plug in numbers close to the asymptotes. Like over here, what do we plug in? I plug in 1 and 2, right? And negative 1 and negative 2. And I have 1, 1/2, negative 1, negative half, right? Now look over here. I probably could plug in, if I'm going 2 left, probably take away 2 from these. So negative 1 and 0 might be good ideas to plug in. And negative 3 and negative 4 might be good ones to plug in. And if I'm going 3 up, let's add 3 to y. So if I plug in negative 1, I should get 4. Plug in 0, I should get 3.5. And I should get 2 and 2.5, I think. Yeah. So you have negative 1 comma 4. 0 comma 3.5. Negative 3 comma 2. Negative 4 comma 2.5. Personally, if you have the asymptotes in the right place, you really don't need to plot points. You know the person will look like that. Just gonna have points so you have an accurate graph. But that's what I do. Does that make sense? So now we can answer these questions. Domain, range, intercepts, blah, 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 whatever, right? Domain is not all real. It's gonna be all real except what number for the domain? Except which one? Except negative 2. The range is not all real. It's all real except what number? Well, y value is not okay. Look at the graph. Well, y value is not covered. For
3.
3. Good. 3. Yep. All real except 3. Okay. Ah, geez. Intercepts. There was y-intercept. We already got it at 0.35. The x-intercept is a little tricky to solve for. Kind of don't feel like solving that. But if you were to, well, first of all, I would adjust the question so you don't have to solve it. So I want to prevent you from ask that question in the first place. But let's just do it anyway.
Do you make the test or like CPM make them?
No, we put it together. Well, CPM just guides the curriculum, but it's up to us how we want to ask. It's what we feel you guys will be successful with and what we've covered with you guys.
Wow.
I'll get to in a moment. So -7/3. Because my thoughts keep changing on that. So -7/3 is your x-intercept. Asymptotes, we got it out of the way. That's x equals -2, y equals 3. And then the end behavior, as x values increase, y values get to 0. Sorry, 3. 3 in each case. My apologies. So that's what we see there. They're getting closer to 3. Okay. So that's a rational function. We're going to do more of this next week. As for the final, so John, to answer your question, I think really just because we have so many different topics that are not really interlinked, that's why I'm doing these quizzes. Like obviously logs don't correlate to matrices, right? Matrices don't correlate to trig. There's so many different things so I think that's what happened. I think people just got overwhelmed, especially after APs. That's why I'm doing these quizzes like this. So the hope is that by doing it this way, so yeah. Because I really didn't quiz much last year, so that's why I'm putting this on me. I don't think I prepared my students well enough. So
Can you give us the final from last year?
well, I can't do that.
Practice.
I could put together some review set for sure.
Oh,
Yeah, no, that's not a problem. All right, so now for number 2, and then we'll do the next page and we'll wrap up the notes. Okay, for number 2, we have the asymptotes already. Where are my asymptotes, guys? At y equals -2, where else? I say -5 actually, because every tick mark is 2 units. So every tick mark is 2 units. So that's clearly -2. And then that's -4 and -6, halfway between -5, right? Yeah. So okay. And I don't have any other points on the graph. So I'm just going to say this. Y equals, now in general, it looks like this. X minus h plus k. K, I know it's kind of weird. I know K is a vertical shift, but it's actually going to impact it's actually going to impact the horizontal asymptotes. And the H is going to be impacted by the vertical asymptotes. And we'll put 1 up top because I didn't give any of the points in the graph. So we can't really solve for A. So what value of X would not be okay? -5, right? So you can put X plus 5. If -5 is not okay, you have to put -X plus 5. -2. And that's how you write the equation from the graph. These problems I like a lot because it really kind of forces you to think backwards, and that's a great way to think about the stuff. Does that make sense how I got that equation? Cool? Okay. Okay, move on to the last page. I know. Terribly exciting stuff. All right. No, it's all good. Don't worry about it. I don't care. I know, man. All right. Okay. So last page. Let's look at 1 over x again. And let's look at this. Now this one looks a little funky. 3x plus over x plus 2. Is that division? Yes. That is division.
Can we do like the x minus 2 times x minus 2 or no?
This is what we're gonna do. We're gonna do the box. So we're gonna do this. It's actually pretty easy.
X minus 2.
X and 2 and 3x. So you're still gonna do the division. What do you multiply x with 3x?
2.
Nope.
2.
Multiply. 3. Not add. Multiply. Okay, good.
When we have to use polynomial division,
Mhm.
like just for this unit,
Mhm.
can we use the synthetic division?
Yeah, if you know about it, sure. Yes, you can. Actually, I'll do synthetic division. It is, yeah. it's a little limited though. That's my only hesitation. It's a little limited because if I ask you to divide by x squared plus 4, you can't do synthetic division for that.
Yeah.
But you probably learn from a tutor. Yes, and I would have done the same thing. Or actually, I talked to your tutor.
Okay.
Yeah. Okay. Yes. All right. Anyway, let's get back to this problem, guys. What do you multiply? Sorry, 3 times 2 is 6. Okay. What do you have to add to 6 to get to 7? 1. So this will be now this is weird because it's a remainder, right? Because it's a remainder.
That oh.
Yeah, because it's a remainder, it's gonna be plus 1 over x. Plus you multiply x by 1 over x to get to 1.
How did you get plus 1 over that?
Because it's a remainder.
Because it's a remainder. That's why it's a remainder. So this can be rewritten like this. Over x plus 2. My apologies. So it's gonna be 3. So what happens if I multiply x plus 2 by 3 plus 1 over x plus 2, I do get 3x plus 7. Now, to answer your question, Nathan, if I do synthetic division, this is a neat thing that probably the rest of class is not seeing. Do you set up like this?
Yeah.
And you put these numbers here, 3 and 7.
So easy, gone.
Okay, then what do you put in the upper left corner?
But the factor you had, so -2.
So what makes it a 0, right?
Yeah,
And then you bring the 3 down.
So
You multiply. Actually, chapter 2 would tell you this. And those that 3 and 1 are the coefficients. Yeah.
I don't get it.
Oh, and then the 3.
I'll do it next week, you guys.
Plus 2. Oh.
It's so light.
So the way it works, actually, let's back up and let's go to a.
Learning that or no?
Yes, it takes like
I'm asking the teacher.
10
Are you the
seconds to
teacher?
learn.
Hey guys, I will teach it, but I am the teacher. Yes.
Yeah,
Is it worth? Is it worth learning?
Yes, it is.
Why haven't you taught it before?
Because I was getting there. That's why. But also it's limited too. I want to give you something that's more universal. I was gonna yes. Okay, so let's look at some we have done from the homework, right? Here we go. All right. So to answer your question about synthetic division, right? So like for example, part B.
Yeah.
Was homework. Okay. So guys, quiet, please. Let me talk. Thank you. All right. So John. All right. So here we're dividing all this junk by x minus 2. So Nathan, why don't you talk us through it?
So we put 2.
2 on the
2 in the top.
right, because 2 is a x-intercept of x minus 2,
Yep.
right? And then we put over here,
Coefficients that we have.
which are what? 1.
1, -6, 18.
Nope.
What?
0.
Why?
There's no x squared. I threw a curveball.
Oh,
Yeah, I threw a curveball. Yeah.
wait, if it's just 18x, then it's still 1. Oh,
Yeah.
right. Oh, it's the
Okay, guys, the way this works, this is called synthetic division. The way this works is that anytime you are missing a term, you have to put 0 as a placeholder. So you have to remember to do that. There's no x squared term, so you have to put 0 as a placeholder. Now, so here's how it gets this.
Wait, how did we get here?
You weren't listening when I just
Okay,
I don't remember.
if you guys, I will teach you if you guys listen. Thank you.
So wait, hold on. Where'd you get the 2? Is that because it's -2? So,
The
Yeah.
2, I get the 2 because that makes that 0.
so if that was +2, it'd be you put -2.
yeah,
Correct.
correct.
Yeah.
Okay.
Then,
I'm talking to him.
then the coefficients, right? These are my coefficients, 1,
Yeah.
-6, 18, -4. Because there's no x squared term, I have to put 0 as a placeholder.
Okay.
So that's 0.
So
So
that's
you're
0.
just putting the coefficients right now.
Correct.
Okay.
Now, this is the part where I need you guys to focus. This is the part where people get lost. I'm recording all this right now.
Where's that page?
It's a homework. It's page I don't know, 8, I think. I think it's page 8.
Just there.
All right.
Answered 1, by the way, yeah.
All right. Now the way this works, you bring the 1 down, you multiply and add 2 to, sorry, you multiply 2 to 1, which is 2. And then you add -6 and 2 is -4. Then you rinse and repeat. What's 2 times -4? -8. You add, which is -8. Multiply, which is -16. You add, which is 2. Multiply, which is 4. And you get 0. Look at these numbers here. 1, -4, -8, and 2. Those are the same exact numbers I saw here.
Yep.
So I would agree. This is actually more efficient if you're dividing by a linear factor. X minus 2, X minus 3. Where this fails, or it's going to be more challenging, is for part A, because the coefficient is not X. It's not 1 in front of X. It's 3X.
3x minus 1.
Or if I did something like X squared minus 2, like it's not linear, synthetic division fails completely.
Okay.
So it is limited. But yes, you do need to know, especially as we move on to calculus. It is a skill you will need to know. And I was going to teach it next week. But yeah, okay. But thank you for bringing it up. I appreciate it. Okay, anyway, coming back here again. So this right here, as we did division, was this, because we do need to finish talking about this problem. Okay. So this can be rewritten. John. This can be rewritten like this if you do the division. Either you do synthetic division like what Nathan suggested, or you do the area division, which I did not too long ago. Either way, you have a remainder of 1. So it can be rewritten this way. So now, what are my asymptotes for this? So if y equals 3 plus 1 over x, sorry, 3 plus 1 over x plus 2, what's my vertical asymptote? Guys, please. Thank you. Let me finish. What's my vertical asymptotes? Negative what?
2.
Negative 2, good. And how about the horizontal asymptote? Y equals positive 3. You always keep it the same. The intercepts, just plug in 0 for x. It's not that hard. You get 3.5. If you plug in 0 for y and solve for x, you're only going to solve for the top, because only top is going to be 0. That should be 0 equals 3x plus 7. That should be pretty easy. Negative 7/3. Just like we got before. So also have negative 7/3 comma 0 as an intercept. Yeah, John, go John.
What percent of the final was grade?
20%. I know. That's why we're taking it seriously. Okay. So a great question that I do not know. I'm gonna assume, because most of the APs are already set up in the practice gym, it's probably gonna be in the practice gym for the non-ASC students. And the ASC students will probably be in the library.
No, I thought it was downstairs in that room. What's it called?
Cor unum, maybe. Cor unum, maybe. I don't know. But see, remember, seniors are gone, right? Because seniors are gone. And also all the APs, AP Calculus and AP Statistics have already tested. So there might be fewer AC students. I don't know. I'm not. But everyone's testing on the same time slot. So I don't know. Okay. So anyway, that's how this looks, guys. If you were to graph it, I know you guys can graph it. So let's just move on to the last problem. Okay, last problem, and we're all done for today. Oof. Okay, well, actually, can you read the instructions some more?
Simplify each of the following complex.
Complex, good. It is a complex fraction because it looks complex, 100%. But how do we make it look simple? How do we simplify it? Here's what we do. I'm gonna really teach you guys a quick and easy way to do this problem. How many fractions do you see here?
3.
Great.
4.
Well, technically 4. Well, yeah, there's a big one. Yeah.
In the shirt.
But the of all the little ones, little fractions.
3.
Little. Good, perfect. Okay. And by the way, 6 is a fraction. It's 6 over 1. Great. Okay. Here's a question. What's the least common denominator of all these fractions?
X.
Higher.
X
X
squared.
Higher.
No.
1.
3x.
3x squared. Thank you.
Oh my.
How is that the lowest?
Yeah,
How is
what?
it the least?
Least common denominator.
Oh.
What am I going to make as my least common denominator to combine these?
I thought you were talking about like 4 and 1.
No. We're talking about multiples, not fact. You're talking about factors. It's okay. It's all good. All right. It's all good. All right. Here's what you're going to do. Every term, not just fractions, but even whole numbers like 6, get multiplied by 3x squared. Think about it. Here's what's going to happen. You have 12x squared over x minus 15x squared over 3x squared. Sorry, it's x squared. My bad. All over the giant fraction here, 24x squared over x squared plus 18x squared. Okay. To me personally, I think this is the best way to do it. because now you're just one step away from having this problem done. You really turn this to really 2-step problem. Actually, people take like 7, 8 steps, like, oh geez, it gets crazy. And it was crazy on the final last year. But we're gonna do better this year.
Let's hope.
So 4 over x, I multiply 3x squared.
What was the class average last year?
I will tell you in a moment. Let me finish. Negative 3x
Over
times
under,
3x squared.
over under 60.
What was over that?
Over under 70.
It was over 7. Okay, guys, let me
It was
finish,
not
please.
70.
Let me finish. Thank you. 8 over x squared times 3. John, guys. Times 6 over 3x squared. That's what I did. I multiply everything by 3x squared. And I'm not doing the top and bottom, just the top. Because 3x squared on its own is 3x squared over 1, right? So I'm just multiplying each of the tops by 3x squared. Now let's reduce. What does this reduce to?
Can you also multiply it by like 8 over x squared minus 6?
No, I'm gonna do it this way.
You know what I'm talking about though?
Well, let me finish this way. Hold on. Because I don't really pay attention to you. All right. So sorry. What does that reduce to? 12x minus 5. Keep going. You're doing great. Plus. Boom. Done.
What?
There you go. It's the same exact thing. And here now, here's how you can verify. I want to verify it. All right, plug in 1 for x. That's 7 over 42. Plug in 1 for x here. 4 minus 5/3 over 8 plus 6. That's going to be 12/3. Yes. Yeah. So you get 7/3 over 14. If you were to clean it up, you will get 7 out of 42. You should always guarantee anything you plug into the original is the same as plugging into the simplified form. That's how it would do it. Now, John, now I'm ready to listen to you. What were you gonna say?
Like, you know how like you taught us the other day to like multiply the bottom and the top by like the bottom fraction, but instead of like plus, it's like minus.
Okay, that's a conjugate. That's a completely different thing. That's if you have x-intercepts. That's
I'm just
that's like I taught you how to bake a cake. Now I teach you how to barbecue. Totally different skill set. We're outside. We're not inside a kitchen anymore. We're outdoors. Totally different thing that you're asking. Yeah, that's if like we're telling the Great Gatsby, but you read Catcher in the Rye. You read the wrong book. Okay, I'll stop because I don't want to be patronizing.
I'm just hearing.
Okay, one more, guys, and we're done. Okay, now this one's a little crazy. However, apply negative exponent to the base. Guys. Yeah, well, yeah, everyone's okay. All right. So x is -1. Only the x is written to negative. Let's make it 1 over x. Y -2. Only y is written to -2. Apply it to y. So you have 1 over x plus 8 over 1 plus x. I should write as x over 1, I suppose. Plus 1 over y squared. Now, we have how many fractions? We have 4 fractions, but really only 2 true fractions. 1 over x, 1 over y squared. These are not common factors, clearly. They're totally not like terms. So what I'm going to write is my LCD, is my least common denominator. What am I going to write? Almost. XY squared. Good. So you multiply each fraction by it, but that means that only the tops get multiplied, not the bottoms. Only the tops do. So you have xy squared over x plus 8xy squared over x squared y squared plus x squared y squared over y squared. I'm distributing. That's all I'm doing. I'm distributing x, y squared to each of these things here. Now, how's that reduce?
Sorry, y squared.
Y squared, good. And 8xy squared stays as is. X squared, y squared, and right plus x. So that's how you can re-express it. I want to say it's necessarily simpler, but this is the way to re-express it. Okay, that completes the notes for today. We only got a few more minutes, so you guys just relax. Get extra donut. Talk about the words are screwed. I don't know. Yeah, unless Curry comes back.